Hi everyone, I'm Michelle, as thanks Robert. I'm here today to talk about machine learning and really about delivering innovative solutions to complex problems. I work for RPS and I'm a data scientist there. I think to kickstart us, we'll first look at really what is data. Data is one of the most valuable assets that a business can have, and it potentially has a tremendous impact on its long-term success. It's facts and statistics collected together for reference or analysis. Every day you could be gathering thousands, if not millions, of different data points, and it allows organizations to effectively determine the cause of problems, then visualize relationships between what's happening in different locations, departments, and systems. Data helps you to understand and improve business processes so you can reduce wasted money and time. So I think one of the biggest things that people maybe don't really think about, you think I have data, but really what is good data? Good data is just that. It's data you've collected with a good data strategy in mind. It's data you collect, you're cleaning it, you're enriching it, you're transforming it. You want to make it insightful with the sole goal of improving your decision making. Good data derives the data strategy from the company strategy, feeding it into the data decision cycle. Bad data has like a lot of initiatives flying around, but doesn't really have a coherent data strategy. Bad data happens when you try and let the data shape the data strategy and not really the other way around. So just basically you have like a lot of data everywhere. It's all bad data is when you have it, it's all misjointed, and it can maybe not make a lot of sense. That's why you need your data strategy coming from your company strategy. So I guess one of the big things is what really is data science. A lot of people, when I say I'm a data scientist, they look at me and go, oh, what's that? Data scientists are analytical experts who utilize their skills in both technology and social science to find trends, extract knowledge and insights, and manage messy or noisy, structured and non-structured data. They can be from sources, everyday stuff that you're doing, your normal stuff you're in work. A lot of people work with, CSVs or stuff from the internet, but it can be like, smart devices, social media feeds, and emails, really stuff that doesn't fit very neatly into a database. And to this, you want to apply knowledge and actionable insights. Data scientists use industry knowledge, contextual understanding, and a skepticism of existing assumptions. And this is to uncover solutions to business challenges. So a data scientist role comprises of computer science, statistics, and mathematics. They analyze, process, and model data, and then interpret results for actionable plans for companies and other organizations. So what is like the data science process? Because it's great saying that's what a data science does, but a lot of people then need to know, how do we do this? So data science encompasses preparing data for analysis. This includes cleaning it, aggregating it, and manipulating the data to perform advanced data analysis. This is one of the big things, like when someone's asking me, how would I do this? I say, just be aware, your data mining and your data cleaning, this takes up a lot of the time. It's really, that's one of your most important things, because you're not going to get a good model. You're not going to get good results coming out if you don't have good data to start with. So the data cleaning can be like, fixing your inconsistencies, handling your missing values, which a lot of people would say, oh, there's not much missing. There always is. And it always needs a bit of prep work. Then you go into your, data exploration. This is using your analytic applications and then reviewing these results to uncover patterns and enable business leaders to draw informed insights. You would have feature engineering to construct more meaningful data from the raw stuff that you have. And then some companies they maybe want to skip the modeling. They maybe just want to go into data visualization. And this is something that I'll show you later in the presentation. But then this is where, your predictive modeling comes in. This is training your machine learning models, evaluating the performance, and using metrics to make different predictions. So the big one, what is artificial intelligence? We hear this talked about all the time, but I don't think half people have a clue even what it is. Artificial intelligence is a popular branch of computer science that concerns building intelligent smart systems that are capable of performing intelligent tasks. Machine learning is a subset of artificial intelligence that includes techniques to enable machines to improve at tasks with experience. So this includes something that we call deep learning. There are actually many different types of machine learning. Supervised learning, just like you see as a teacher showing them what to do, is when you feed a model input data and an associated label. So it has a target label there with it. Unsupervised machine learning is another method primarily used to decipher and expose, your hidden patterns, your natural groupings. We only provide it the input data, there's no targets or labels. And then reinforcement learning, this is a little different, where it is learning to make a sequence of decisions where the machine can learn to achieve a goal in complex environments, such as like chess games, where the ultimate goal is to maximize the reward. And then our other one is our deep learning. It's a subset of machine learning, and it's based on neural networks to permit a machine to train itself to perform a task. So I found this really interesting. I think it just shows the progression that there is in the industry. If you look at from up until 2010, sorry, you had the I repeat to I imitate, and this was your naive algorithms in machine learning. And then the progression 2010 to 2018, you got your deep learning. This is, I guess you can contact this with how look at like Alexa coming out and different things like this that are all using AI. There's a lot more interest in the industry. And then from 2018 to 2022, it went from I learn to learn. And then now finally you're at the machines are becoming that intelligent that they're able to contribute and they're exchanging. With the rapid advancements in deep learning and machine learning, the tech industry, it was really transformed radically. Don't know where we'll be in 10 years or so. But why would you want to use AI? So the biggest thing is for data-driven decisions. You need to ask yourself, is your task genuinely data-driven? For most people, I could assume, yes, it is. Look at what we do in everyday life. You wake up, you're on your phone, you're driving in your car, you go to a coffee machine, a lot of things, there's so much data everywhere. But then if your task is data-driven, do you have the data to support it? So, you've got tabular data, you've got your time series, which is, your continuous data streams, your text, so it's like reports, notes, image and video, and then you've got your audio, your speech and music. Another thing is then like the scale. Do you need the scale that automation provides? Because some of these things, they could be very minimal, but do you really want to use, your machine learning, your artificial intelligence to do this? But I think a good way to look at this is I may have, image files, I may have audio files and some record data, all of which have, useful information for making good decisions. But the great thing about artificial intelligence is the model design is very flexible, and you can configure these to receive information from different sources. So although if it was, if you're not using AI, like if it was me doing it on my own, it would take me a long time to process, image files and then the records and then something else. But the great thing about AI is we can combine everything together. It's quite like, a human brain. It's quite like us. We use multiple senses to perceive and process the world around us and make decisions. And that's what we can train these artificial models to do. Another massive thing is the market trends. By 2025, the global AI market is expected to be almost 60 billion. AI-powered voice assistants are to reach 8 billion by 2023. And this blew my mind. Global GDP will grow by 15.7 trillion by 2030, all thanks to artificial intelligence. Already 77% of the devices that we use feature one form of AI or another. And that's because AI can improve and increase business productivity by 40%. Even if you look at, again, as I was talking about before, Alexa or even Siri, look at Alexa, it has 66,000 skills in it. Like I even use it on my own home for, turning on the lights, turning off TV, and it's just what they can do is incredible. But I suppose in terms of work, why you would use it would be the speed. It's repetitive learning, discovery through data. It's just so much faster than if someone was to go through things manually and try and, extract a lot of not just it, but then information from that's useful to make decisions on. The precision, it's incredibly accurate. When you have an algorithm running, it's going to be consistent. It's not like us humans that if we were to do something by hand, we get distracted looking out the window or something like that. It's always going to have the same levels of accuracy. It's effective. It adds intelligence to existing products. The cost of it, the fact that how much more data it can analyze is incredible. And it is a big cost saving, not just in terms of money, monetary cost, but time and resource. And then the fact that it's always learning. AI adapts through progressive learning algorithms. So just looking at a few real world examples. The biggest one, I think this is why I got into data science and looking at all this, was healthcare. It's massive what it can do. I've looked a bit at this before myself, and it's into cancer research. So what you would do is you get CT scans of patients, and there's a lot of we all know ourselves, sometimes it can take a long time for people to get a diagnosis. But what about the people who definitely didn't? Maybe they presented symptoms, but if they got a CT scan, the consultant would be able to say, oh, they definitely don't have cancer. So what we can do is feed in CT scans, and a lot of this is from open source data you can access online. And they're able to look, we can train the algorithm to assess and say, definitely not cancer, probably not cancer, maybe cancer, and definitely cancer. And then, if you're in the different scales, the ones that are at the lowest scale where the algorithm can say it's definitely not cancer, then the consultant doesn't have to spend their time looking at that person, and they're in the all clear. It saves people a lot of stress, as well as, waiting about on scans and the consultant looking at it and everything. A big one again would be different healthcare problems, like say, for example, diabetes. People use scanners, and these scanners are connected through different applications on their phone. And what they can do is it consistently will, every 15 minutes, it'll check a person's blood sugars. And then that goes in up on their phone, and they have a little graph that they can track. It's just really incredible there. In the financial industry, according to Forbes, 70% of financial firms are using machine learning to predict cash flow events, adjusting credit scores, and detecting fraud. So if they see, for example, you're on holiday and you take money out, you're only on holiday, and obviously sometimes your card gets blocked. That's usually an algorithm that then could look and say, you're not usually spent money there, is this fraud? And that's where the bank would ring up and check with you that it's definitely you. Then a common one that I think, it's become more common now, self-driving cars. If you look at Tesla and how popular that's becoming. Recommendation systems with, Netflix. And then you've got your AI chatbots, with Alexa. This uses natural language processing, and it's actually nearly scary with how good it is becoming, responding to you. It nearly feels like you're talking to another person. And then if you look at social media, there's Twitter. It's a really interesting one that it uses AI to identify hate speech, fake news, and illegal content. In one 6-month period, the platform removed nearly 300,000 terrorist accounts that have been identified by AI. So what it does is endless. A massive one that we will all be very aware of is Amazon. Amazon personalized, it can create individualized recommendations for customers. So this is not only improving the customer experience, but it boosts sales for Amazon as well. 35% of Amazon's revenue is generated by its recommendation engine. And I don't know about you, but for me, if I buy something and it shows me something else, I'll say, oh yeah, I'll have that too. And then there was a Salesforce was looking at, one of these companies is called Room and Board, and they use predictive intelligence. They're an online furniture retailer. They use predictive intelligence to increase their returns on investment by a massive 2,900%. And that was simply by predicting and recommending additional purchases to its shoppers. So, what AI can do is endless. I just think it's fascinating. But then I guess AI examples that we have worked on in RPS. One of our biggest ones recently is landmine detection. And I know for everyone, you see in the news what's happening and you think, oh, how can AI help here? Well, what we have is object detection. We have, it's called a black box algorithm. You give a model true and false samples. Now in this example here, the input images will be, the true samples are planes. We have, you know, these look like planes, they are planes, they're labeled as planes. But then you have your false examples, and they would be things like the sky or a bird that looks like a plane. What the network does is it receives an input image, does its our objective after training is to predict the output image accurately. So if it goes in as a plane, it's labeled as a plane, we want it to come out like that. For landmine prediction, we want to predict if a landmine is present and where it is. So to train our neural network, we had to get clear landmine samples. These are both positive and negative. And I hope you can see here, it's a little blurry. These are kind of the images. This is what I mean about sometimes the data is not the best, but these are quite good. But these are different landmines. You can see the little white circles. What we would do is then we extract the positive samples and the negative. And there's just a bit of an example of what they'll look like. And then what we do is extract binary masks for each of our samples. So for wherever a landmine has been detected, so you know we would then have a box over these, and that becomes our mask that we can use for training. So supervised deep learning models are largely reliant on the amount of data available during training. Data augmentation, which is what I'm showing here in the little GIF you can see moving about, it synthesizes new data by modifying the original images. So in addition to the exponential growth of training samples, data augmentation introduces sample diversity. Just for example, and I'm just this, you know, in our landmine, we're looking at different terrains that you could possibly identify landmines on. So if we're changing the brightness in training samples, that may reflect, you know, brightness differences during the different times of the day when the aerial footage is being captured. And then also, you know, if some of the samples then that we have are in low light, it becomes a lot easier to then detect in highlight. So it's given, you know, a lot of different sample diversity. And these augmented images, along with the original images, are fed into the neural network. So as you can see here, that's a little input. That's our input image, our input mask, and then our output. So we decide on different parameters, but what happens is the training data is fed into the bottom layer, which is our input layer, which you can see to the left-hand side, and it passes through the succeeding layers, getting multiplied and added together in complex ways until it finally arrives radically transformed at the output layer. It's kind of magical because the numbers start to adjust themselves, trying to find the best path for maximum prediction. So really what we're aiming to do is get as close to our little input mask as our output heat map, because that's where we're wanting to identify the landmines. Okay, so our neural network for this had 2 million trainable parameters. We monitor, you know, the key performance metrics, so it'd be like our accuracies, our loss rates, and what we do is we optimize them and use hyperparameter tuning algorithms. This is just showing you, by the way, this GIF just it actually working in real time. You know, you can see our original images, our ground truth, and at the minute it's predicting, and that was our output. The output is obviously that heat map. So a yellow shape point indicates a detected landmine, and other lighter colours, usually surrounding, you know, the possibly identified landmine. It's all around there, you can see them, indicate no detection. This output mask will be merged with the original file's geospatial information. And then, that's been extracted from the TIFF files that we got on input. And then we provide exact coordinates of the predicted landmines. So really what this does is it allows for accurate detection and therefore safe detonation of the landmines. Why are we doing this? I suppose the humanitarian impact, you know, it's estimated that there's at least 110 million military munitions and explosives of concerned devices in the world. And these are all different, you know, shapes, sizes, compositions. And if you even look at the statistics here, it's scary. In 2020, there was 7,073 casualties, you know, 2,492 people killed. It's obviously humanitarian side of things. It's just to reduce the amount of, you know, casualties there are by giving people who are looking for these landmines a better area to look at. Because if we can focus it in one space, then they're being able to, you know, get in there and get them down there quicker. It's much faster than manually counting landmines from an ortho image. And it's quantitative and reproducible, unlike subjective, you know, human error prone detection. So the next project I'm going to look at was our NI water project, and the whole focus of this is to optimize treatment to drive efficiencies. So RPS were appointed by NI Water to undertake a proof of concept study aimed at using advanced technologies to drive efficiencies in potable water treatment. And this looks at, anomaly detection and event classification. You're looking at, you want to see different correlations, patterns, and trends. And this is something that's really important, I guess, for companies that they have so much historical data. You could have 10 years worth of stuff, but you're kind of going, I don't know where to start. I don't know what to do. And that's what the great thing is about AI. It takes all that data and it'll show you, in winter there tends to be more, which I think, people tend to understand. In winter there tends to be more rain or whatever. So you need to reduce or increase, if there's more mud, you need to increase the amount of chemicals going in. But the whole reason is that we can expose these complex relationships between external environmental parameters and the raw water quality. We wanted to get then optimal dosing rates, and then a big one as well, early warning alerts. So for example, you could use the weather. If you know that it's going to say it's going to rain tomorrow or for the next week, well then maybe you want to turn off, put pumps on, or different things like that. RPS then predicted flow at a decommissioned gauge using upstream flow across 0.6 million 15-minute observations. I think even here, just look at the scale that AI can go on, the amount of data it can use. And we trained it on 67% of the data and tested it in 33. So what we do is then we used a predictive analytics to then look at what we had, and it will then fill the missing data using the trained model. Habitat mapping was another big project, and RPS applied for automatic habitat mapping for a large SAC in Northern Ireland. We wanted to predict it based on previous ecological surveys and produce a habitat map. It was for the Upper Loch Iron. The amount of space that it had to cover, that would take months to complete on foot. And there was data from a lot of different resources, so that had to be very well managed. So what I got was 2 high-resolution ortho photographs were used, including then time series from Google Earth and an NDVI to produce accurate training data for model training. We used semantic segmentation, and this was purely because we got the best results. It had high resolution and human-like outputs. I think this is something to note as well. There's not always one size fits all. With AI, there can be a lot of different algorithms which might work. Just for this particular thing we wanted to do, semantic segmentation worked better. RPS trained and evaluated a fully connected deep convolutional neural network to complete this segmentation and classification. So this is just kind of what it would look like. It helps you to look at, where there was, for example, marshy grassland, or, the open waters where it was green. And it helps you just to monitor, visualize, analyze, and understand the species populations and distributions. This allowed us to help develop the better conservation management plans. It just really was about again, time and resource that this could take people. If you had to cover this on foot, it would take so much longer, and it may be a lot less effective and accurate. And that's why, these cost and resource intensive tasks can be automated, and this allows professionals to focus their efforts on other tasks. So one of the ones we've been working on recently is our marine mammal detection. So we're collaborating with our office in North America to undertake an exciting study that aims to provide marine mammal detection during offshore seismic surveys. At the minute, what they do is there's manual listening and recording from marine biologists, and they're on board a vessel. And if they hear something, what they do is they press record, and then they wait until they don't hear something, and then they can signal to the ship to, turn off. So the seismic exploration for offshore vessels, it involves the use of high-powered air guns. They blast compressed air about every 12 seconds for weeks to months at a time. Not only does the intense sounding mask whale calls, so over vast stretches of the ocean, it causes commercial species of fish to scatter, leading fishermen all over the world to seek compensation for losses. And there's a lot of work going on, especially in the Gulf of Mexico at the minute, which is the most heavily polluted, I suppose, area, with all these oil rigs and everything. So what we wanted to do was then needed better, a more objective detection for these landmines. We wanted to reduce the false positives, and this would improve seismic exploration planning and mitigation. So we got data. There was thousands of audio clips, like a lot of data. And what we had to do then was split it into training and test data. We would use, what we did is from the sound, you can create a spectrogram. So whatever we hear, if you heard me talking, this can go on a spectrogram and you'll be able to see the little movements in it. And then this will allow us to try out some vocal separation. Again, this is just to show you. There's the wheel at the bottom. The sound goes into a hydrophone. This comes up to a sound card. And what we would do is our RPS's detector, our interface, would kind of coincide with the one they have at the minute, the PalmGuard one. But what it allows is, humans are humans. We need to go eat, we need to sleep, we need to go to the bathroom. There's all different things. But what this allows is for us always to have some algorithm there that's constantly looking and finding where these marine mammals are. So if you see, on the little grass here, this is our input spectrogram, and then we have our mask, just like previously we had with the landmine stuff, and then our prediction. So why do you want to do this as well? Well, obviously mainly it's to keep these marine mammals safe. Marine mammals depend on their hearing to navigate, communicate, and to catch prey. But sound levels in the ocean are rising constantly. Even low levels of sonar, which do not cause direct damage to whales, could still cause harm by triggering, behavioural changes. In this audio-focused environment, man-made noises are a major threat. They drown out the calls that marine mammals rely on, causing so many problems, from mass mortalities to chronic, debilitating harm of specific populations. So we want to mitigate the impacts from this. As well, it's then, looking at improved, efficient detection of pods of dolphins and whales, because people are not going to be able to do this. They're going to miss something. And hopefully that our, algorithm that we've created would be able to catch this. Again, then the time and resource, it's allowing marine biologists, people on the vessel to be able to use their skills at other tasks. Instead of sitting listening all day, they could be doing something else. And then obviously the savings for the oil rigs themselves, if they did harm a marine mammal, what can actually happen is, they get fined. And then the good thing is that these savings that they make can be used to invest in better detection equipment. So here's some other examples RPS has been using marine learning techniques to develop solutions and test the capabilities of this technology for our industry. Our coastal team have been researching the use of Earth observation remote sensing data combined with machine learning to automatically map and detect changes over time. We've completed a small internal proof of concept to prove these algorithms can detect birds in images. And this is, again, to reduce time for human interpretation. But there's so many other uses and examples of using AI and machine learning across the business. But again, it goes back to this. Why are we using it? You can see in the examples we have, it's for the speed, the precision, the effectiveness, the cost, and the fact that it's always learning. Even if you look at, our landmine detection or our marine mammal model, whenever we're recording that data, we can feed that back into the model and it keeps getting smarter and smarter and smarter, hopefully so that in the future it's amazing and we don't need to have any, it could work 100%. We don't know that all around, but it's one of the possibilities. And when it becomes so intelligent, obviously it's so much more accurate and effective. So how does this work for business then? There's a lot of key players in the data process. You've got people like myself, your data science, your programmers, and we're the people who are cleaning, analyzing, modeling, your data analysts. These are the people with basic coding skills, who are analytical thinkers, and tend to be good with statistics. But the people as well that aren't thought about as often would be the less technical, and these are the more business development roles. They understand the complex systems at a high level. They're instrumental in bid proposals and tenders. and identifying areas that the business can improve, and then the development opportunities, and just having a really good understanding of what amazing things AI and machine learning can do. So the benefits, machine learning can review large volumes of data very quickly and discover so many hidden trends and patterns. The predictive capabilities of it can surpass human expert judgment. Again, as we've discussed, with it just learning more and more and more, that it's just getting better and better and better at what they're able to do after they're trained. The machine learning algorithms can continue to learn and improve, but they can decipher and cut through very high dimensional data to expose insights and develop predictive capabilities. So, think of companies that have 10 years worth of data. They're just so intelligent. They're able to get through the data and give really good, valuable insights in that potentially me or you could not have been able to do. It's so wide and diverse. It's becoming part of every software we use, and it will grow, and so will clients' expectations. They're going to grow with it. But best of all, machine learning software is open source, so most of the development is free in terms of software. Though costs obviously are incurred whenever you're deploying it in the real world. Hurdles to overcome. There are potential barriers, and the solutions really are, if you're looking at feeding out the right data, we want to have a clean data structure, like we talked about before, having a good company strategy that then feeds into a data strategy, and just really capturing the good data that we can work with on the modeling and the visualization. You want to, sort through the jargon, have people who have an understanding of it, of the solutions. You want to have protected data, which is using your appropriate storage platforms. You want to have a sound business model instead of, a lack of a coordinated data strategy. And you need to have involvement from all areas of the business. This I think this really feeds into, skills shortages. A lot of people are only really starting to understand what good this kind of area of work can do and what benefits it can bring to a company. And then you need skilled employees from a wide variety of backgrounds to really address this issue. So how can you get involved? Let's get past one. So, as we've went through, the data science kind of process life cycle, our raw data, you're looking at databasing and having a structured data storage. You could use things like SQL, Delta Lake. Then you've got, your data wrangling, which is your cleaning of your data, your data manipulation, and you'll be using things like Python, Pandas. I would really heavily use a lot, sklearn. Then you go into, your model training. This is developing the machine learning models. They can be logical, geometric, or probabilistic. And this is using Keras, TensorFlow, and then you'll want to deploy them. But I think the big thing to note is it's rarely using just one thing. It's a package. It's all of these different softwares together. And that's why at RPS, we're building systems and solutions that are cost effective. They have an impact and they are beneficial to the clients. We're trying to modernize and change the way we do these things, and there's always room for growth. But really the best thing is they're all open source and they're all great tools as well. So I talked about before, some people may not want to do the modeling side of things, but they want to use AI for their visualizations. Today, especially in our modern world, people want more. Data visualizations need to be more than just a visual representation of data. It needs to be scientific, it needs to be visual, and more importantly, really insightful. In that, it should go just beyond basic important. We don't need just, Word documents, PDFs of everything. Although they're good and you can add links into stuff here. But it's good to have something that people can, get interactive with. And it must present analytical reason through, interactive visual interfaces. So, for example, this driving demo, I think it's so interesting. You can see the grass moving. You can see an interactive path going. You can adjust it yourself. And this is all done using open source applications. It's not something, you need to have the skills, and a lot of people can develop them, but all the software applications are out there to use. The great thing, there's another one, it's called Shiny App. The great thing is you can host everything at the back end, but the nice customization is at the front, and it can be really, really tailored to what you want it to be. So This is Power BI. I guess a lot of people would have heard of it. You know, it's Microsoft, and you can bring it in from SharePoint, everything. But I think a good point to make is around 90% of the stuff that we use is open source, although it doesn't mean it's completely free. This depends on your end product. You know, do you want to allow this to share it for free or not? So it's free in terms of, you know, you're doing the prototypes and you're testing, but whenever you want to actually commercialize it, if you know, we're going to sell it, you can't take something from the open source community and sell it without licensing. But in terms of commercializing, again, for what you're getting out of, you know, data that potentially you couldn't have done a lot with before, the cost is quite minimal, because you're coming out with really great products. So that's kind of my bit done. And if there's any questions, I am definitely happy to answer.
Thanks very much, Michelle. That was really interesting. It definitely sounds like AI is the way of the future. No, it was really good. I maybe kick off the Q&A. I see there's one question in there, but give time people to put in a few questions. But there was a number of software there. Python was probably the only one I recognized. But do they need specialized computers to run these software packages, or I suppose there's different softwares that need different things?
Yeah, no, that's the great thing. They don't. You know, you can have just a normal laptop. You can have your MacBook, anything. And what you can do is every computer has this capability. You can download something called Anaconda. It has so many interactive development environments that then you can just go, you can get started. A great one would be, you know, Jupyter Notebook. You can just play about in. But no, as long as you have a computer, you're good to go. And I guess whenever you go into the side of like commercializing it, then you're looking at having, you know, higher GPU and storage and security. But to get started, no, it can work in anything.
Yeah, very good. And just another one for myself. It sounds like we're all going to get replaced by AI algorithms. So is there any limitations to it? Is there anything that humans can actually do better than AI?
Well, yeah, of course, at the minute, because we need to train these algorithms, you know, there needs to be a lot of the training samples already there. So if you're looking at, for the landmines, a computer's not just going to automatically know that's a landmine there anyway. So yeah, they do need to have human guidance, so they do. But then we'll talk this conversation in 10 years and see what happens then. Yeah.
Right on. Okay, we'll go to the Q&A. So we've got quite a few coming through there. So one from Gabriella. Intelligence is also about emotional intelligence, empathy, compassion. How do we reconcile decisions requiring use of ethics with AI? So there's this very interesting, this is a bit like the self-driving cars and their collision decision making. It's probably quite a big question in AI.
Sorry, can I get the question again? I was looking for it. I'm trying to get the chat up.
So intelligence is also about emotional intelligence, empathy, compassion. How do we reconcile decisions requiring the use of ethics with AI?
Yeah, there's actually a lot of companies out there who are working with emotional data. So they're looking at, and I hope this kind of answering what you're asking, but they're looking at people's faces and then being able to identify, you know, if they're happy, if they're sad. So there's a lot of companies out there who are looking at that already. I guess, sorry, is that kind of?
Yeah, I think that's what Gabrielle's getting at. I sort of tie it in with the self-driving cars and it may decide to avoid a lorry to go into another collision. There is an ethical aspect to it. That how do you actually program that into AI?
Yeah, and if you even look at the examples we were talking about there with the landmine detection, the marine mammal stuff, the whole humanitarian side of it is so important, and I think that's what drives a lot of people into it. And again, from like me going into data science, that all came from, you know, actually it was from my sister's diabetic, and it was that I wanted to look into something that I could then help with. And you look at what she has now, she's got an app that it can look at her diabetes and, you know, track it by the hour, and then if she's low, it alerts to family members, and that's all what comes with AI. And I think it's just incredible what it can do.
Yeah. Ruth has a question. You had an example. Oh, it's moved. You had an example on one of your slides being an AI in river geomorphology modeling. Could you elaborate on what you've done in this space?
I think Chris, probably you're a bit better than on that one.
Yeah, Robert, could you just repeat that? I'm only seeing some of the questions coming through here.
So there's an example on river geomorphology modeling, and would just like to elaborate on what you've done in that space.
Unfortunately, the river geomorphology is not my area of expertise. We have a whole team dedicated to rivers, so unfortunately, we'll have to get back to you on that.
Okay.
I can answer that, Robert, if that's okay. The geomorphology example was about edge detection to monitor and potentially predict the change basically along rivers given a set of input images over time. So much like a lot of the work that Chris might be involved in there, although his is more based on coastal erosion, but the same principle applies, that if you have a number of images over time that show you the condition and the extent of the edge of a river as it progresses and erodes away or accretion occurs at other areas, effectively what you can do is potentially predict in 5 years or in 10 years where the river meanders will be.
Okay. Thanks, Paddy. We have another question here. So how long do you think it takes to begin to take an idea from concept through the solution? Is there an iterative process? So how long roughly does it take to go from concept to solution?
Yeah, how long is a piece of string, I guess, in some points. But it really does go back to that project life cycle that we looked at before. The majority of the time can be cleaning, and that can take weeks. It really can take weeks of doing it. But some things can take us, 6 weeks. Some things can take you 12 weeks. It all depends on the complexity of the problem. If we're looking at something like, the landmine detection, you've got terabytes of data to go through. That's a lot of pre-processing on GIS before you even get to your modeling stage. And then after you get to your modeling, you have to look at all the metrics you have. You have to, refine your model. And then there's a whole point of like choosing what model to go with. As I said before, there's lots of model architectures out there. So yeah, it's a bit of a difficult question to answer. But it depends on how dedicated and how intensive, I guess, someone is working on the project.
Yeah, okay. Another question, how can we use AI in urban drainage modeling? Can we use flood predictions for solution development?
I'll take that if you want, Michelle.
Yeah.
Urban prediction modeling, I suppose in our section here in water and environment, we see obviously a lot of big numeric models being conducted, and actually that whole process seems to be a big trial of sort of parameterizing these numeric models and rerunning the outputs in order to achieve some sort of calibration. And where we have seen maybe a potential place for sort of machine learning in there is the bit that fits in between those iterations where you're trying to achieve a parameterized model that meets the calibration the best, and rather than iterating over and over again, rather taking your outputs of those models and using them these sort of maybe more specialized algorithms to interpolate between your iterations to say, well, these are the these parameters or these models that you're running. You're running like a big grid search in order to try and find what's the best sort of set of parameters for your urban drainage model, and really the best answers are sort of somewhere in the middle of all of your runs. And I think feeding the outputs of those model runs might get you there quicker. Feeding those into machine learning algorithms to kind of go, well, based on your trials, this is where the sweet spot should be, and then using that as a focus point to change your model parameters and rerun, and hopefully it will get you to a more optimum answer quicker rather than really selecting or iteratively trying to improve your models. So that's one particular way. We don't get away from the actual models that are there currently, The softwares that are being used currently seem to be good at what they do, but it's just how many times you have to iterate and recalibrate those models seems to be a big time consumer, and the AI and ML might fit in there nicely to reduce how many iterations you may have to do.
Okay, thanks, Paddy. A bit of a business question. How aware are your clients of the opportunities of data science for their problems?
Probably not as aware as they could be. I think they need plenty of successful examples. I think Michelle would second that as well. I mean, we work obviously in a multidisciplinary office with lots of different departments, and there's probably only 3 to 4 of the departments actually starting to harness the data science approaches. Now, that's not to say that data science always has to bring in machine learning. It doesn't. It's just data science is about being efficient with the data and exposing the patterns and doing the analysis efficiently and cleaning the data properly. All too often, the data can get mixed up and mangled, and that can result in kind of false metrics or false statistics coming out. Data science sort of makes sure that the answers that you get out are the correct answers. So when we conduct data science, we are highly confident of the results and the answers that we get out, and therefore we are also confident of our decision making that follows.
Yeah, I think I'd second that definitely, that a lot of companies as well, and there's so many clients that just are not aware of the scale of what data science and even just the analytics can do. Yeah, it's incredible.
Okay, thanks, guys. There's one question, a good question in the chat actually. Do you find many clients lack the historic data to train AI? Do you recommend people start collecting as much data as possible now, or does this risk too much poorly structured data to clean properly?
Yeah, so I guess this is a whole argument about the good data versus bad data. If you were just telling the company, store everything, store all the data, give me everything, if they don't have a good data strategy, it's going to be very, very difficult after, although it can be done, but it's a lot more difficult to go through the data after. A lot of companies do tend to have a lot of historical data because they didn't know before what the purpose of the data was going to be used for. And I think that, but then at some point, yes, there is problems where they do not have, they have gaps in their data for any particular reason. Like if we were working within NI water or somewhere like that, and turns out one of the gauges was off or something like that. But what we can do is then use our predictive analytics to then fill forward potential missing pieces of data. So a lot of time we can synthesize and augment that. But yeah, as long as there's a good data strategy, then they should be collecting as much data as possible.
And a great example of actually that sort of meets that question as well is the example that Michelle gave about the marine mammal detection. We did not enter that proof of concept study with perfect data at all. Our North American group has over 200 or 300 terabytes of audio data that they've recorded over the last 10-15 years during their seismic surveys. So obviously under proof of concept, it's unlikely we're going to be able to cover that whole swathe of data. So we isolate a certain percentage of that data and enter into a phase of what you should have been doing or what you could have been doing, i.e. we have 3 or 4 passive acoustic monitoring operatives track through. I think they went through something like 30,000 audio files, and they labeled the individual biological acoustic signals. So all the true dolphins and whale sounds that were across every single audio file. And while that 30,000 is such a small fraction of everything that they have available, it was enough to bring us to a point where we have models of adequate performance. And then that offers an opportunity that we can use those models to scale up and actually track through the backlog of the terabytes of data and start labeling those parts automatically. And then that will probably follow a further review, but there has to be that initial kind of investment and effort to create just enough training data to fulfill a proof of concept and to give people confidence that it's going to work. And once you can prove it starts to work, then these algorithms basically have no real plateau in terms of performance. The rule is really that the more data you feed them, the better they get.
Yeah. We'll take one more question here. It's maybe a tricky one, going back to the ethics again. But Duncan says, I don't recall you mentioned any drawbacks for AI. What is the future for AI really all rosy? What about unintended consequences? So how do we avoid the unintended consequences that might come out of AI?
I can mention something that just ethics is a huge topic in itself on AI, the use of it. And it's probably quite heavily related to the application in which you're deploying it. Anything where there's humans involved, if there's any recognition of people's faces, obviously there's going to be ethical issues. There definitely needs to be more regulations brought in there on the safe use of AI. One thing in particular is the use of our algorithms, or rather to be careful of the misuse of the algorithms also. And most of the things that we're trying to do to limit that potential is obviously to ensure that the algorithms themselves are stored securely, that nobody can hack in and get them and take them and misuse them in some way. A landmine detection algorithm might be one, for example, where it could be misused by the wrong group of people, where they can pick up on where the landmines are and then therefore deploy new threats elsewhere. So there's the amount of places of misuse is probably quite infinite in how many places it could be misused, or even that the algorithms could be used and their outputs misjudged or taken as gospel. Again, in a scenario of landmine detection, that's a big issue, which is basically why we make sure that we document and record and document the limitations and the caveats associated with all models. And the fact is that you cannot take away the human factor in any of these applications. We do not accept that the algorithm will be all rosy and do everything 100% better than a human. We are not there yet. And it will be a while before we do get there. So I think it just needs people to understand that you cannot, that we're not looking to take away the human here. It is an augmentation tool. It is there to enhance and potentially speed things up, but the ultimate decision making is never taken away from the human. So there's nobody actually replaced. It's only to enhance and improve a process and not to make a final call or a decision.
Okay, I think we'll wrap it up there, guys. That was a brilliant presentation. I think everybody will agree. Real fascinating subject, and something that's just going to become more and more part of our lives in years to come. So I just want to say thanks very much to Michelle. Brilliant presentation, well presented and well put together. And also thanks to Chris and Paddy for helping take some of the questions there. There's quite a lot of questions come through there. And finally, thanks to Barbara and CIWEM for helping facilitate this webinar. And also thank you to all the people who attended and tuned in. So I hope to see you all again at the next CIWEM NI webinar again. That's on the 6th of April. So thank you, everybody, and enjoy the rest of your evening. Thank you. Bye-bye.